Welcome to Brain Vision.
So for this problem, we have an initial pressure and an initial volume, and then a final volume, and we want to know what the final pressure is. And so we can use the relation P1 V1 equals P2 V2. Since the multiplication of pressure and volume will always be a constant, and therefore this equation always holds true for an ideal gas. And so pressure 1 is 1.22 atmospheres, and volume 1 is 13.9 liters. Now pressure 2 is unknown, that's what we're looking for, and volume 2 is 10.3 liters. And so if we rearrange this equation to solve for pressure 2, we get that P1 V1 over V2 equals P2. And so plugging in the values here, we get 1.22 atmospheres times 13.9 liters over 10.3 liters. And so our liter units cancel and we get our final answer in atmospheres, which is what we want. And when we solve this, we get that the pressure is 1.65 atmospheres. And so this answer makes sense since it went up from our original pressure. And if the volume decreases, but the number of moles stays the same, the pressure has to go up. Since it's the same amount of particles in a smaller container, they will therefore have more collisions and increase the pressure. So the final answer is 1.65 atmospheres.